Silicon carbide heating element, the component that converts electrical energy into radiant heat inside industrial furnaces. The black central section is the hot zone, where electrical resistance is highest, where current becomes heat, and where temperatures reach up to 1600 degrees Celsius. The white sections at each end are the cold ends, impregnated with metallic silicon to lower their resistance, designed to stay cool enough to pass through the furnace wall and connect to the power supply without damaging the seals or the aluminum braided straps. The white sections at each end are the cold ends impregnated with metallic silicon to lower their resistance, designed to stay cool enough to pass through the furnace wall and connect to the power supply without damaging the seals or the aluminum braided straps. Between them, a transition shoulder manages the thermal gradient from furnace temperature to ambient. You see two forms here: solid rods for standard furnace heating, and a hollow tube for applications requiring higher surface loading or specific thermal profiles. What allows a silicon carbide ceramic heating element to heat an entire furnace chamber to 1600 degrees Celsius? Start with the resistance profile. The hot zone operates at a calibrated electrical resistance that converts current into intense far-infrared radiation, the most efficient mode of heat transfer for sintering ceramics, melting glass, and treating metals. The cold ends, impregnated with silicon metal, carry the same current at a fraction of the resistance, as low as 1/40th of the hot zone value. That 1:40 ratio concentrates virtually all the electrical energy in the furnace chamber, not in the furnace wall or the terminal connections. The element is fully self-supporting. It mounts horizontally or vertically through the furnace wall without external brackets, simplifying installation and replacement. And it operates directly in air atmosphere up to 1600 degrees Celsius, no protective gas, no vacuum, no sealed chamber required. Silicon carbide heating elements come in geometries matched to each furnace design. The straight rod, the simplest and most widely used, mounts horizontally through opposite furnace walls. The tube type offers a hollow cross-section for higher surface area per unit length, increasing radiant output in compact chambers. U-type elements bring both terminals through the same wall, simplifying wiring on one side. And spiral elements, formed from thin wall reaction-bonded silicon carbide, deliver rapid thermal response for processes that demand fast ramp rates. Every element is specified by 5 parameters: outer diameter, hot zone length, cold end length, overall length, and target resistance, all customizable to your furnace drawing. The far infrared wavelength emitted by silicon carbide couples efficiently with oxide ceramic materials, transferring energy into the workpiece volume rather than just heating the surface. This radiant coupling is what produces the uniform temperature distribution that sintering demands. Every grain boundary in the green body must reach the same temperature for the ceramic to densify consistently. The self-supporting design means each element simply slides through a hole in the furnace wall, with the cold ends protruding outside for electrical connection via aluminum braided straps to a voltage-adjustable transformer. No internal brackets, no suspended fixtures. Installation and replacement happen without rebuilding any part of the furnace lining. Over months of operation, the silicon carbide gradually oxidizes at the surface, and the element resistance slowly rises, an aging behavior inherent to all silicon carbide heaters. The solution is straightforward. The transformer steps up the voltage to maintain the same power output through the higher resistance. A well-managed element set runs for thousands of hours before the resistance rises beyond the transformer range and replacement becomes necessary. For ceramics manufacturers running continuous or batch sintering kilns, whether firing advanced technical ceramics at 1600 degrees Celsius or tableware at 1200 degrees Celsius, silicon carbide heating elements remain the standard heat source. Self-supporting, air-compatible, radiantly efficient, and field replaceable without furnace downtime.